Hi, in this investigatory project, we're going to show you how to make some bioplastic in your own households. By the end of this, we are going to see the results of the bioplastics we made and be able to compare them. Bioplastic is a form of plastic derived from renewable biomass sources, such as cornstarch, rather than conventional plastics made from petroleum, which is a non-renewable source. In the experiment, we are going to do 3 bioplastics to test its properties. For the first bioplastic, we would be needing the following materials: a heating device, an iron stand or tripod, beaker or a pan, and a stirring rod or silicone spatula, 5 milliliters of vinegar, 5 milliliters glycerin, 16 milliliters of water, and 1 teaspoon of cornstarch, and an aluminum foil or your decent container for the bioplastic to be spread on and tried. Now start by charging in the 16 milliliters of water into the beaker, then add the cornstarch and start mixing well until you get a homogeneous suspension. Now add the 5 milliliters of glycerin and the 5 milliliters of vinegar. The 5 milliliters of glycerin, mix it well until you get a homogeneous suspension. Then add the 5 milliliters of vinegar. Now, turn on the heat and start mixing until it hurts. As you can see, that the mixture looks like a milk mixture at first. Now what's the chemistry behind this bioplastic? A polymer is the main building block of all plastics. Think of it as a long chain of large molecules, also called monomers. An ideal plastic would have very long straight polymer chains, allowing it to be strong and flexible. Starch is made of 2 basic components, amylose and amyloseptane. Amylose is a very long and straight polymer like we want. Amylopectin, on the other hand, is a branched and short polymer, meaning it will yield brittle and weak plastic. There are 2 things we will be doing to enhance the properties of our plastic. The first is a simple technique called acid hydrolysis. By adding a small amount of vinegar to the plastic, we can break up some of the branches of the amylopectin, which otherwise would have made it brittle. Secondly, we will be adding a plasticizer. The easiest to obtain from a drugstore, grocery store, or from your school lab is called glycerin. Glycerin acts like a lubricant at the molecular level. Imagine a bowl of sticky pasta that you add butter to so that it doesn't all stick together. If you want very pliable plastic, for a bag for instance, you would add more glycerin, and if you wanted stiff plastic, then you would add less glycerin. Now you can see that from the milky appearance, the mixture starts to get thick and sticky. Continue mixing and watch until your mixture turns into an opaque, goopy-like gel. Just continue stirring until it turns a bit more clear like that. Quickly pour your mixture into the cooling sheet of your preference and spread it out the way you like it. Leave it and wait for it to dry for almost a week. After a couple of hours of drying, this is how it looks like. On the first try of our experiment, the mistake made the plastic fail was that it still lacked more of the heating process, because as you reach the point of the mixture starting to become thick and sticky but not yet opaque, you already turned off the heat and spread it out already into the cooling sheet, which was wrong. For the second and third bioplastics, the process would be the same, it's just that amount of glycerin would differ in each bioplastic. For the second bioplastic, you would be needing the same amount of materials, but this time the amount of glycerin would increase to 10 ml. Again, mix all of the ingredients into the beaker and mix it well until you get a homogeneous suspension. Turn the heat on and stir until the mixture gets sticky, then on opaque goopy-like gel. Pour it again quickly on your preferred cooling sheet, spread and let it dry. After a couple of hours, this is how it looks like. And for the last bioplastic, same amounts again, and this time, the amount of glycerin would be reduced to 2.5 milliliters. For fun and for interest, we added a drop of food color. It won't really affect the result of the plastic, so don't worry. Stir the mixture again until it turns an opaque and a thicky goopy-like gel. If it's already okay, pour the mixture quickly and spread into your cooling sheet and leave for drying. In the first try of our experiment, this is how the 3 bioplastics of our first trial look like after being spread out into the cooling sheet. Pour the mixtures, the second bioplastic, and the third bioplastic. And then after a couple of hours, cracks were visible in the bioplastic. In the second try of our experiment, this is also how the tree looked like after being spread out. And after a couple of hours, this is our simple investigator project on how to make a household plastic.